Okay, on this example, we are given that sine of theta is 3 over 7, and we're also told that theta is in quadrant number 1. That means that all of our trig ratios are going to be positive in the first quadrant. Okay, so as we get going on this, we want to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Now, these two we're just going to use the formulas for. As far as tangent goes, I'm going to think about tangent as sine of 2 theta over cosine of 2 theta using that quotient identity, and I think that'll be the most helpful. So to get going on this, we could just plug in what we know already. We can say this is 2 times 3/7 can get plugged in there, but we don't know what cosine of theta is yet. So we're going to have to do a little bit of work to find that. How I like doing these is drawing myself a triangle, a nice right triangle. I'm going to label this angle to be our theta, and I know from sohcahtoa that sine is opposite over hypotenuse. So I'm going to use that, and we're going to try to find our adjacent side. That way we can get cosine. Okay, so a little bit of work with the Pythagorean theorem. We can say a squared plus 3 squared equals 7 squared. So a squared plus 9 equals 49. A squared is going to be 40, and we can apply a square root to both sides. I'm not worried about the positive and negative in this case because it's going to be positive because everything has to be in the first quadrant. All right, that's going to allow us to calculate cosine of theta if this side length is the square root of 40, which we could reduce down. We can say this is going to be the adjacent square root of 40 over the hypotenuse. So square root of 40 over 7. All right, from here, a little bit of reducing down, we can multiply our numerators together, and I'm visualizing this as 2 over 1. So we have 2 times 3 makes 6, square root of 40, over 7 times 7 makes 49. And then let's reduce down that square root of 40 just a little bit. We can think of that as meaning 6 times the square root of 4 times 10. I would factor it this way because 4 is a perfect square, and we're allowed to apply a square root to each one of these individually. Therefore, giving us, instead of the square root of 4, we can put 2 in that place. So 6 times 2 is going to make 12, square root of 10 over 49. Okay, so now we have sine of 2 theta. Next, let's work on finding cosine of 2 theta. Well, again, we know some of this information. We've collected all of it at this point. We can say cosine squared, cosine squared is cosine square root of 40 over 7 squared minus sine of theta is 3/7. So 3 over 7 squared, which works out being when you have the square root of 40 and you square it, you're going to get 40. And 7 times 7 makes 49 for our denominator, minus 3 times 3 over 7 times 7 works out to be 31/49. All right. Lastly, what we want to do is find tangent of 2 theta. So tangent of 2 theta, using this quotient identity, instead of the other formula, what we can do is we can set up the sine of 2 theta, which we said was 12 square root of 10 over 49, divided by the cosine of 2 theta, which was 31/49. All right, 49. From here, I would elect to multiply numerator and denominator both by 49 to clear out these fractions within fractions. It's multiplying the same thing, numerator and denominator, but what that allows us to do is these make a 1 and these make a 1. So our final answer is going to be we're left with 12 square root of 10 over 31. And that's going to be our tangent of 2 theta. I hope this helps. What I would suggest is draw a triangle, even if it's not in quadrant 1. Get your side lengths, think sohcahtoa, and then you can get your cosine. Use these formulas and plug in, simplify down where possible. All right, good luck.